Hey guys, I want to quickly go over ocean movement. We're going to talk a little bit about ocean currents here and what drives those. There's no guided notes to this section. However, you still need to know this information, and it's kind of all laid out in the notes format already taken in your notes packet. So we want to start with the uneven heating of the Earth's surface and what drives that here. Move this down away so you can see all the information here. The Earth's major source of energy is the sun. The sun usually is the driving force, or the sun is the driving force behind most processes on Earth. Okay. The Earth is constantly receiving solar energy, but in different areas and different amounts of solar energies in different areas, and this affects weather and climate. So, as I said, different areas of Earth receive different amounts of sunlight, and you can see here how that could possibly affect the weather and climate of these different regions. The equator is going to receive the most amount of sunlight because the Earth is closer to being directly overhead year-round than it is any other place on Earth. This increases the amount of heat energy received and explains why areas near the equator have tropical climates. The poles receive the least amount of sunlight, which is why they have the colder climates. Solar energy received by the Earth causes ocean currents, winds, and climate differences. So, what is an ocean current? The uneven heating of Earth's surface creates energy flow. Wind and ocean currents flow from warmer areas to colder areas, which means that they travel from the equator towards the poles. This means that coastal land temperatures don't fluctuate or go up and down extreme because the water nearby doesn't fluctuate as much, and that has an effect on the temperature of the land mass near the water. An ocean current is a large volume of water flowing in a certain direction. Wind-driven currents are called surface currents, so these are the ones that affect the water on top, while warm currents affect water a little bit lower, and there's also something called a density-driven current that is determined by the amount of salt in there. So surface currents carry warm and cold water horizontally across the ocean's surface. Surface currents extend to about 400 meters below the surface, and they move as fast as about 100 kilometers a day, which is pretty quick. Earth's major wind belts, called the prevailing winds, influence the formation of ocean currents and the direction that they move. A rip current, which is something that you've probably heard if you've ever been to the beach, is a narrow, powerful surface current which flows away from the shore. It's caused by pressure building up from uneven buildup of water and waves, and they can flow very quickly and can be difficult to detect until you're in one, which is why your parents always tell you be careful of that rip tide or be careful of that rip current when you go to the beach. It's that what you can feel tugging at your ankles when you're in the water. Okay, a rip currents are responsible for about 150 deaths per year. And about 80% of all beach rescues are related to the rip currents because people get caught in them and get pushed out to the outside. Okay, rip currents don't pull swimmers under, they flow outward. So it's not going to drag you under the water, it's going to push you out towards the sea. So if you ever get caught, here's a helpful hint, swim parallel to the shore until you're out of the current, and then you can swim back to shore. Because water has a much higher heat capacity, it absorbs and lets go of heat more slowly than land does. Water temperature will increase and decrease less than land temperatures will. For example, during the daytime, land temperatures might change by tens of degrees, while water temperatures will only change by a small amount. An upwelling causes cold, nutrient-rich water from the deep ocean to rise to the surface. Upwelling is a vertical movement of water towards the ocean surface. It occurs when wind blows across the ocean surface and pushes water away from a deep area, and that warm water that gets pushed out is replaced by cold, nutrient-rich water that rises to replace it. Upwelling often occurs along coastlines where there's a lot of winds that come off the water, and upwelling brings, as I said, cold, nutrient-rich water from deep in the ocean to the Earth's surface. El Niño and La Niña. El Niño is a change in water temperature in the Pacific Ocean that produces a warm current, and La Niña is a change in temperature in the eastern Pacific that causes surface temperature to be much colder than usual. So El Niño causes an unusually warm current, La Niña usually cold current. Both El Niño and La Niña can cause flooding, too much rain, and drought, which is too little rain, in different places on Earth. During these periods of flooding, upwelling will not occur where it normally does, and this can affect the nutrient levels of fish and other sea life. The Coriolis effect is the clockwise and counterclockwise spinning in the northern and southern hemisphere, and winds will appear to deflect to the east or west depending on the direction that the wind is traveling. Coriolis effect is the movement of wind and water to the right or left and is caused by the rotation of the Earth, and is one of the examples that we know Earth is spinning. It causes fluids such as air and water to curve to the right in the northern hemisphere in a clockwise direction and counterclockwise in the southern hemisphere. The shapes of the continents and other masses will affect how the flow and speed and currents occur. Currents form a small or large loop and move at different speeds depending on the land masses they contact. A buoy records data about surface ocean temperatures and transmit and send that information to satellite in space and to scientists. As I said before, density currents are a type of vertical current that carries water from the surface to the deeper parts of the ocean. Density currents are caused by changes in density rather than the wind or temperature. Density currents circulate thermal energy, nutrients, and gases. Warm water currents and cold water currents affect climate and weather in different ways. Regions near warm water currents are often going to be warmer and wetter than regions near cold water currents. The Gulf Stream is a warm water current that affects coastal areas in the southwestern United States by transferring lots of thermal energy and moisture to the surrounding airs. The cold and California current affects coastal areas of the southwestern United States. The Great Ocean Conveyor Belt is a name for a model of the large system of ocean currents that affects weather and climate by circulating thermal energy around the Earth. In this model, high salinity water cools and sinks in the northern Atlantic, and deep water returns to the surface in the Indian and Pacific Oceans through upwelling. Scientists estimate that conveyor belt model takes about 1,000 years to complete a cycle. And then lastly here you can see the parts of the wave. You can pause this here and see what all these, you are responsible for this information. Thanks guys, that's it for today.